Hello, everyone. Thanks for joining us today. If it's your first time here, my name is Lean, and I'm a solutions marketer at Tanai. Today, I have with me three LabVIEW champions eager to discuss LabVIEW measurement code done right. Now, depending on the problem you're trying to solve, it could just be taking a one-off measurement, or it could be automating your measurements. You could be working on process control. Some measurements could be complex, where maybe you're stimulating a device under test and grabbing data at the same time. Sometimes you're dealing with high channel counts. Sometimes you're not even sure yet what hardware you will have at your disposal to use. In all cases, the design decisions that you make early on when building your measurement code could impact its longevity and reusability. So good planning goes a long way. And here to walk us through the considerations to take and the best practices are Brian, Casey, and Steve. So let's start first with a round of introductions. Brian, you're on top left for me. You wanna start first?
Sure. My name is Brian Powell. My background is in computer science, and I actually worked at NI for over 26 years, mostly in the LabVIEW R&D team. And then after I left NI in 2014, I worked in healthcare for a while, and then at a local startup. And then in 2019, I started my own consulting company that's kind of a combination of LabVIEW and software development, as well as helping companies build strong engineering teams. And so I'm really passionate about like company culture and organizational culture. And I'm just grateful to be here today. Thanks.
Thanks for joining us. Steve?
Hi, I'm Steve Watts. I've come from test engineering out of factories. I've written books about LabVIEW. Two books now about LabVIEW. Started GDevCon, made all sorts of trouble. LabVIEW champion, CLA. Troublemaker.
You're downplaying your role, but we'll hear more from you throughout the panel. And Casey.
Hey, everyone. My name is Casey May. I am a partner with Zyah Solutions, which is a LabVIEW consulting company. I've been using LabVIEW since about 2005. I'm a CLA, CLED, and LabVIEW champion. I'm also a founding member of the Actor Framework Guild. If anybody likes Actor Framework, we can talk about that later. I'm also on a committee member on the GID exchange. That's the G Central ID exchange for sharing community tools and that sort of thing. So I'm passionate about LabVIEW and building this community.
Love it. So I feel like we have the right people in the room. So let's dive in. And I want to start by expanding on something that I think a lot of engineers and a lot of LabVIEW users agree on, but I want to dig a tiny bit deeper into it. LabVIEW is great at talking to hardware. Steve, you mentioned you had a story about your first time using hardware with LabVIEW. Maybe we can start there.
Yes, so I had LabVIEW inflicted on me by my company, and as a Pascal programmer at the time, I was not happy about it. So I had a project which was a SCADA system, which was measuring furnace temperatures around the factory. And it took me a few months to do. It was a fairly big project. It took me a few months to do in Turbo Pascal. And then I got this toy language, which in the late 90s, which I said, oh, I don't want to do this. And I rewrote the entire project as my first project and all its horribleness. But it only took me 6 days. And after that, I thought, there's something to this. And it was all the same hardware. It was pretty much the same set of tools. And it being a SCADA package, you had all the built-in tools in Turbo Pascal as well to do the work. So it wasn't as if, I wasn't comparing like for like. It was very, very similar sort of starting points. But whoa, it was quicker. So much quicker. So yeah, it was that sort of made me enthusiastic about our little language, our little toy language.
Yeah, I've never heard of described as toy language. I love it. And you were sold. You were sold on the toy.
Sold.
I love that. And of course, Brian and Casey, feel free to jump in. Is there something is there a reason that this is almost universal, that when you think, I've heard it said, obviously I'm at an eye, so I'm biased. I hear it said a lot, but I've heard a lot of customers say, you know, whenever there's hardware, I think of LabVIEW first. Do you think what's the main part of that? What's behind that sentiment?
I think for me, you know, I started at NI before there was any data acquisition products. It was just GPIB, and so, you know, really it was more of a question of, you know, what third-party hardware do you want to talk to over GPIB? And so we had somebody who focused on writing instrument drivers and just, you know, cranking out interfaces from LabVIEW to other instruments. Since that was at the very beginning, that was back in LabVIEW 1 days. And then, you know, I think for a while I managed what we called the LabVIEW Measurements Group, which was responsible for where all the I/O, you know, where LabVIEW met all of the I/O. And so it was never a question of could LabVIEW talk to something, but just sort of how. You know, is it over a serial port? Is it over GPIB? Is it a plug-in card like a data acquisition card? Is it over the network? You know, LabVIEW has always had that strong connectivity built into it. And so regardless of whatever kind of measurement or switching or control system that you're trying to write, we knew that LabVIEW could do it, and it was just kind of baked into what we did.
Yeah, kind of building on that, the Zyah team, we recently worked with a client in the kind of augmented virtual reality space, testing some of the materials and that sort of thing. And we were involved in a lot of the hardware selection, and we use a combination of both NI hardware and other third-party hardware. But it's nice because you don't have to worry about LabVIEW talking with those things, right? You know that LabVIEW is going to work with the NI hardware. We use compact DACs. We were doing like pressure monitoring, temperature monitoring, DI, DO, and then we also use a bunch of non-NI stuff because that's what fit the bill, and we could communicate with that over serial or Ethernet or any other protocols. And that's not something that was like a low risk area for the solution that we were building for this customer. We didn't have to worry about that. We could focus on the things that were important to them, that were custom to them, and knew that LabVIEW would do the job for the rest of it.
Awesome. I like the low risk. Yeah.
I think you used the word risk as well, which is the other aspect I think that's probably worth considering, as all of us are in the business of delivering projects, usually at our own risk, you know. So actually having the safety of knowing that we've got systems and tools that we can actually use and help us is hugely beneficial.
Yeah, I hear that. And I think I like, Brian, how you put it. It's not if you could connect with LabVIEW, it's how. I really like the way that you phrased that. Well, okay, well, so we seem to be on the same page. We have LabVIEW. We've heard that it's great with hardware, and we have a problem at hand. We need to take some measurements. We need to code for that. On a high level, before we dig into the details, what are the first questions we have to answer before we start designing the measurement module? What are things that we have to consider that maybe someone like me who's, you know, I know how to use LabVIEW, but I've never been in a developer position where I've had to develop full programs. I've taken one-off measurements. To me, it's like, oh, drop a DAC Express or do some DACMX and that's it. What are the considerations that we should take first before we start going into the full like measurement code design? And I'll start with, do you want to like volunteer? Or do I pick on people?
I can jump in. I think a big consideration is where you're going to be using the equipment. It's very different if you just have your lab set up with a desktop PC versus something that's going to be remote in the field. You're not going to have access to it very easily. It might be headless. So like what kind of target is it going to run on? And by target, I mean like a Windows PC, a real-time system somewhere. So I think that plays a lot into, if you don't know that right away, that's something you should probably figure out. It's going to drive a lot of other decisions.
I tend to now look at the type of system that it's going to be, and then that dictates the type of interfaces that I insist on now. So, for example, if you're doing long-term testing, I wouldn't allow any USB in that system at all. And that's because USB is part of the, it becomes part of your computer. So when you're running it, it's part of your computer. And if something goes awry and it disappears, it's like you've ripped away part of the computer. And LabVIEW and all software has a really hard time dealing with that and recovering from that. Whereas if it was something like Ethernet, it would be fine. It wouldn't worry about it at all. So I'm tending to do much more distributed Ethernet type systems than I am sort of internal. Whereas if it's a short-term test, absolutely fine, you know, go with it. It doesn't matter. The ramifications aren't the same, you know. It's so those sort of time-based situations are important. Reliability is another important consideration. Standard is very, very important to me. And the other one is dependencies. Is if the driver set is 14 million gigs, then I really worry about that. I always up for the lighter driver sets if I can. I don't like carrying around tons and tons of drivers. And I know within LabVIEW you get that with Macs, and that is tends to be a given. But there is a cost to sort of driver sets. So again, mixing and matching is try and standardize on the types of equipment. If you go with one type, you know, stick with that. And I find I do a lot of academic work. They don't. Academics don't. They just you just get a random box full of random equipment and have to try and make it work. And it always makes for a difficult system to make reliable with that. So yeah, it's that kind of thing that I look out for at the start.
To expand on that last point, it kind of depends on what does the customer already, what are they comfortable with, what do they already have, what do they want to use. You know, I've got one customer who has, you know, 7 Tektronix oscilloscopes in his system, and so, you know, why switch away from Tektronix oscilloscopes? You know, if there's a good reason, we would switch away, but otherwise we would just keep buying Tektronix oscilloscopes because we know LabVIEW can talk to those. I've got another customer who feels like there's one Keithley instrument that's, you know, kind of obsolete, but it does the measurement exactly the way he wants to do the measurement. So we're going to use that Keithley instrument in it. And then you have other customers who don't really know any of that. And so then it's sort of understanding, well, what are the measurements that you want to take and what are some of the best solutions for that? And that's where you can kind of broaden your scope, and you can look at, you know, is there a compact DAC module? Is there a, you know, is this something that a CRIO or an FPGA is needed for, or something like that? You can start to bring, you know, a broader approach to how you select the instrumentation.
I think also going back to something that Steve said about sort of the lifetime of the product, kind of going hand in hand with that is like how, I know it can be hard to kind of predict up front sometimes, but how much you expect it maybe to change or expand. So you might find a solution that is good for the here and now, but maybe in a year, maybe in 5 years, they're going to want to add 100 channels or something like that. And you should be aware, be thinking of ways that you'll be able to do that without having to rewrite your whole system or rebuild your whole system.
Is that where you think software design comes in? Like, is that where good software design at the beginning will, I don't know, help mitigate some of the risks of these changes? Or is it just an evil we'll have to face?
I mean, it's both, right? Because, for example, if you have a compact Rio chassis that doesn't have enough slots or something like that, you're going to have to go through more effort than if you had something that you could just add another card, get some more channels. But yeah, there's definitely a software component to that as well.
Yeah, I think we do system design based on, we like spare capacity. So our designs have spare capacity in the software and in the hardware generally, because you have to understand what's difficult for, your customers, and the difficult thing for your customers is paying an awful lot more for something they've already paid for, you know. And throwing stuff away, and you know, those decisions become very hard for managers. Whereas adding a card, you can just say, well, you've asked for this new thing, we just added a card, everyone looks good. So building always to the ragged edge of what you can do, it doesn't leave you any scope. And hardware's, in a lifetime of a product, hardware's generally the cheaper part of it. The maintenance and the support and the design effort is usually the more expensive part of it, usually.
Mm-hmm.
Well, I think you know, we'll maybe talk about abstraction layers later in this, or you know, in a future webinar. But you know, one of the things that I think is a good software design principle with measurement systems is to isolate the business logic of your application as much as possible from your hardware selection. And so that's the idea of things like instrument drivers, is to make sure that I'm not having to bake in everywhere in my application that I'm using a particular, you know, Keithley oscilloscope or a Keithley DMM, say. Mm-hmm. And so if I can, you know, maybe I'm not going to use that DMM, I'm going to use a Keysight DMM. And so I want to make that as simple a switch as possible without having to change a lot of the code in my application.
It almost sounds like expect change. Even if when you're answering these questions, you go like, nah, this is my system. Always leave that room for change and put that into your design thought for both hardware and software before you proceed. Yes,
even that customer that has that Keithley device that does that exact measurement he wants, I'm going to make sure that it's something we could replace if we needed to with a different model from a different vendor.
Yeah, sounds smart. Sounds like a good idea. Yeah, sorry.
A very early story in the history of SSDC, and this was going back to a very early version of LabVIEW before I was doing LabVIEW. So this was probably 2.5, I think. And a big ATE was built, and it had an oscilloscope and the Visa type commands. And what was happening in 2.5, I don't know, probably Visa didn't exist then, but the actual oscilloscope commands were written out and individually placed everywhere they were needed in the software. And there was no wrapper for that at all. So, of course, when eventually they changed the oscilloscope, they then had to go through all of the software and change the text in all the commands everywhere. And that's probably quite a graphic example about the starting point, what the point of design is. The point of design should be that you replace at its easiest a VI. You know, that should be the easiest, but you replace a library or you replace, but it's a module and you're not actually digging around in the software, changing the code everywhere. So that
helps with testing, right? Because then you have one module to test that it still works with your new oscilloscope, as opposed to I have to test the 100 places that talk to the oscilloscope the old way.
Yeah, and if you think of the horrific status where these are commands in text that spread throughout hundreds and hundreds of VIs, how do you know which ones you've changed? How do you know, the maintenance for that extreme example is very hard, and it started the whole cycle of sort of design thinking where SSDC went down, you know, but again, well before my time. This was early 90s probably, but it was that harsh lesson that sort of set the ball rolling for us.
Yeah, we like to take kind of, as others have alluded to, an iterative approach to the software. So that means kind of thinking about things that could change up front. So keeping things modular, using abstraction layers where it seems appropriate so that it's easy to change some of this stuff out later if and when things do change. Because I think all my time working with LabVIEW as a consultant, especially, I've had a whole 0 projects where everything stayed consistent from the beginning to end. I'm curious for Brian and Steve. I think it's easier to take an iterative approach when it comes to the software and planning ahead for that. I think I've found that it's more difficult, to take an iterative approach to hardware and like, oh, we'll try this and then swap it out, even though the cost, as you pointed out, a lot of the time is overall lower. I'm wondering about your guys' experience with that and how you might approach that when it comes to the hardware selection side of things or design.
I mean, my tendency is I favor things like Serios, for example, purely because they do give a little bit of that. I can, if my initial simple design doesn't work, I can then go on to a slightly more complex design, or go to a slightly more complex design. And I really like using Serios for that. That's one of the reasons I really think they're a breakthrough technology for us. Is I mean, the classic example we did was a comport thing, and it was, you know, your standard 8-bit data, but this needed 9 bits, and there was nothing anywhere. No, you couldn't get 9 bits in LabVIEW anywhere. But because we could go down to the hardware level, we could toggle something in the hardware, and that would emulate 9 bits, and it was all possible. So this thing that was impossible, because we could get down to the FPGA, it became possible. And I like that, but like you say, that's rare and hard. It's I guess your standard sort of switching solutions, multiplexers and matrices allow a certain bit of that. You know, when you're building test systems, there are ways to get a little bit of it, but it's not as easy as in software. No.
Yeah, from my perspective, you know, my software approach is very there's a computer science phrase called "you ain't gonna need it," and so I typically don't design in, I don't over design the software at the beginning. I try to make it as simple and straightforward and focused as possible, and then only after time do I figure out, oh, I need to, you know, this part needs to be enhanced to have more capability. And so then I add it. You know, I know some people who love to design in all this beautiful complexity at the very beginning. And, you know, that way it's there if they do need it. But, you know, in my view, it's like, well, that's just overcomplicating things at the beginning. And I'd rather not do that. You know, when you bring hardware into the equation, though, it sometimes becomes hard, because you really don't want to I want to find the simplest instrument that can do this measurement, knowing that there's a good chance that I'm going to need more digits of precision, or I'm going to need more bandwidth or more channels or something like that. So that's where I usually will spend some more time really trying to understand what are the measurement requirements, and try to anticipate good hardware that will be able to do that capability, but not necessarily build it all into the software at the beginning.
Feels like it's like a similar, like you have similar experiences, just like you tackle them slightly differently, which is interesting, curious. And I think one of the things I heard modularity going around a lot in our last panel discussion was about LabVIEW being modular and how it helps. So it was cool seeing this kind of as a continuation, if we consider them a series of panels. That was really cool to hear. So we've already my next question was going to be like, let's dig a tiny bit deeper. And we've naturally gone there with where do we start? How do we select the hardware that we want to use? What are the things we should avoid? And I think this will follow naturally but then also, how do we choose which software API to use? And Brian, you mentioned this earlier as well. We also have choices of how to communicate with the hardware, serial, Ethernet, GPID. So it's a multifaceted question, but basically we're already kind of there, but let's dig a little bit more. I think let's start with hardware. Steve, you gave a little bit of, well, it depends on is it a long-term project, a short-term project, USB, etc. What other things would we consider, and what are the things we should avoid?
Something I really am keen on is using interfaces that I can fault find. So take CAN bus or ARINC or RS-232, RS-485. You can look at those signals on an oscilloscope, and that tells you an awful lot. And I really appreciate that, being hardware centric. I like to be able to go down to that lower level, and it's saved me an enormous amount of cost and effort and the customer's cost and effort, because I can sort of say, it's this CAN bus, the signal should look like this, here's the scope, this is wrong. And I like Ethernet for that, because you can Wireshark everything and pull everything apart. So I can get down into the really into the details if I need to. I don't want to. This is on a fixed price job when I have to. I just need to. So I tend to avoid driver sets that come as we've done a DLL. I did a motor controller once, and it had a .NET API. And I don't particularly think .NET works very well within LabVIEW. I've never had a very satisfactory experience with it. And so I tend to think, right, what's actually happened? Because in the end, the computer is talking to in this case, the motor driver in some recognizable way. It's not talking to it in .NET, it's talking to it in some other way. And it transpires that all the .NET was doing was building an XML file, which is sent to the, and so, you can actually scrape away a lot of that. So where a lot of companies think they're helping you by wrapping stuff up in DLLs and .NET drivers and things like that, they're actually would be better just to publish the protocols and let us deal with it in primitives. Because again, going back to the dependencies, I'm not lugging DLLs around with me if I don't have to lug them around. So I like protocols I can talk to, and that's worked very well for me. And I work in a lot of environments where actually I don't have connections to internet, and dependencies are a massive pain in the neck. So
I want to add to that, because I have a customer right now that has a robot that does so pharmaceutical application that's filling syringes and things like that, and it's got a .NET interface, and that .NET interface is what is preventing them from upgrading from Windows 7 to Windows 10, because it doesn't work quite right in Windows 10. And so if we had, and it's a USB connected device, there's not really an easy way to know how it's talking to the robot other than you're interacting with this .NET object. And so we're kind of stuck, and we're not getting any support. The people who wrote the .NET interface are gone from the company that makes the robot, so we aren't really getting very good support. So having that kind of closed interface is can have a bigger impact than preventing you from getting an OS upgrade on your computer, for example. One of the things that I also look for, Steve talked about network-based devices, and I used to be part of the LXI consortium, which was the consortium of test and measurement manufacturers that made Ethernet-based devices. And the purpose of the consortium is to basically say, we're not going to compete over interoperability. Let's all agree on how network-based devices should appear on the network. How do you interact with them? How do they get their IP addresses? How do you send commands to them? All these sorts of things that don't make sense for Keysight and National Instruments and Tektronix and Keithley and Rohde and Schwarz to compete on. Instead, let those companies compete on the capabilities of their instrument. And so, for example, with network-based instruments, if I see an LXI logo on the front panel, I'm going to have very high confidence that I'm going to be easily be able to talk to that device. And it's the same thing, once we see GPIB on the back of an instrument, we know we can talk to it. It may not be the fastest interface, but we know we can talk to it. When it's things like RS-232, it starts to raise more questions, because that's where instruments can start to be a little bit more stubborn and persnickety about how they behave. And so that's where you'd like to see that the instrument vendor is paying attention to industry standards and trying to follow them wherever they can.
Yeah, another thing that Steve said that sparked something is just to be aware of, I guess, is bitness of your operating system, right? When you're just selecting things, that's another thing that's bitten me before, right? If you're relying on a third-party driver or something that has DLLs, that are written for 32-bit, and now for some reason you need more memory bandwidth or something. You need to switch to you want to make a 64-bit application, and they're not providing the drivers or that are built for a 64-bit operating system. That can be a showstopper, right? And you have to look for other solutions. So yeah, I vastly prefer also the hardware has it exposes kind of the command set, and you can write your own API for that rather than relying on the manufacturers, even though some of them are good, some of them are not as good. So but having control over that's nice. What you were saying, Brian, about the LXI consortium, it reminds me, this is sort of a tangent, but just what I heard about the airline industry, where airlines used to compete on safety, like ours is more safe, and they decided that that's not something we should be competing on. We should all focus on like having a standard set and like improving safety across the board. And that's when airlines got really safe, right? And they could focus on the other aspects of that. And so similarly with the hardware, like if the instruments, they conform to like a kind of standard, a set of standards that you know that you can rely on, then that's beneficial, I think, as well. I just wanted to, yeah.
Interesting. So I'm hearing that like when the protocols are kind of like packaged, they could do the job. But the second you need to do a little bit more, or like you said, or the second that there's a future update or something changes, that's where they might not be the most ideal. And that's something like, I think it just reminds me of sometimes like if I want a quick job, like a job done quickly, I'll go for whatever first app I find on my phone, versus when it's something that I know I'm going to be working on for a long time, that I know is a big project of mine. I'll do the research and look, and maybe even find an app with a subscription if it's going to give me what I need in the long term. So I don't know if I oversimplified that, but trying to repeat it down. Well, perfect, thanks. And then on the same like choosing the hardware, choosing how you want to communicate, I think we hit on how to communicate. When it comes to the software APIs, are there many decisions to make there, or is it as simple as whatever, I think I'm trying to get to like, I know that there's DAC-MX that we use with a lot of our DAC hardware. Is that always the go-to? Are there sometimes, is there a reason to sometimes go for something else? Yeah. What would you teach me on that?
So I would say, if it's in iHardware, if it's in data acquisition hardware, I would start with the DAC-MX API, right? It's a very, very powerful API. We put a lot of work into that design. And it's scalable, right? It works with the simple hardware, it works with the complex hardware, and it's one API, and it's one kind of one-stop shopping. I also like that it is, has things like the ExpressVI that you mentioned. It's kind of an easy way to understand how you get started. I don't like having ExpressVIs in my application because I want to, more control over, it's a little bit too black box. But one of the things we built in to the ExpressVI and to a lot of the DAC API is that you can like right click on an ExpressVI and tell it, I want to turn this into code. You can, same with, I can configure a task in Max, and I can play around with it in Max and say, okay, this is the kind of measurement that I want to take. And then when you go into LabVIEW and you drop a DAC task control and you say, I want to use this task, you can right click on it and say, turn this configuration into code. And, it's kind of magic how it works using LabVIEW scripting, but it shows me how the kind of medium level of the software is actually written to do the data acquisition. When it comes to third-party instruments, the first place I go to is IDNet, the instrument driver network. It's ni.com/IDNet, and search for the instrument there. Because if I find an instrument driver there for my instrument, I have pretty high confidence that the driver's going to work. Because somebody, the NI has, or at least had, an instrument driver group, I assume they still do, that, makes these drivers and tests these drivers and then kind of keeps them up to date. And so, and for the most part, they cover at least a lot of the capability of the instrument, if not all of the capability of the instrument. And so, I look for there first. And in there, you can find different kinds of instrument drivers. And so there's IV drivers, there's LabVIEW native drivers. I tend to prefer the LabVIEW project style instrument drivers where I've got the source code and I can see inside. But there's also a lot of merit to IV drivers, which, we could talk about at some other point.
We could argue about. I hate IVI.
I was going to say, Steve, do you have anything to say?
I think I hated IVI ever since I think I downloaded the driver set for a Keithley multimeter, which if I'd just done it in Visa commands, it would have been about 15 commands, and it was like 1.6 gig of a driver. It was ridiculous. And I thought, yeah, there's something wrong with this.
I did say start with the LabVIEW drivers and only use IV.
Oh yeah, no. I was nodding to that. Right. But I mean, for all my moaning, it's just having somebody else write code for you is nice, so just drivers is nice. And the nature of LabVIEW is you can open block diagrams and you can open and you can sniff and you can see what's happening in the driver. So actually it's any starting point, because I mean what we tend to do is never have a complete driver set within our code. We always rip it out just to the bits we want, to take a very minimalist approach. So even if I get the drivers, I may not even use those. I may just cut and paste the bits I want into my own driver, just because I can carry it that around. It makes it that much more portable, because if you're writing a test system, you're only going to be using 5% of the instrument's capability for generally. You bought the instrument just for that one job. You're not using it as a multi-purpose instrument. I do a lot of oscilloscope stuff, and I think I go set vertical, set time base. This is my trigger, get data, and that's it. So I used like 5 functions, but you pick up a manual for an oscilloscope and it's got like 50,000 commands that you could possibly use if you wanted to, and so there's a way to minimize some of that effort and having access to it. I mean, I use downloaded drivers all the time, and it's hugely beneficial. And I remember the days of traditional DAC, so I look at DAC MX very fondly. Anyone who's used traditional DAC, and even then we were doing miraculous things with it. Back in the old days, it was you never knew the pain until DAC MX came along, and you looked at it and thought, oh, this thing that was really hard is now quite easy. And that's a testament to design. Again, if something that was hard comes easy, somebody's done a really good job on design. So I appreciate things like that. Can't remember what the question was. I was just talking about DAC.
No worries, this is great. I'm getting the experience of the veteran LabVIEW user that saw pre-DAC MX, because I first learned DAC MX when I learned LabVIEW, but I did support the customer once when I was a technical support engineer, and I was like, what's happening here? So I appreciate the journey that you've taken for sure. Casey, any thoughts from your side on this?
I was just thinking that at the kind of the lower level interacting with the hardware, yes, obviously I'll use the manufacturer's driver if it exists, but I often find myself, this is not contradicting anything anyone else has said too, but I also find that I generally have a higher level driver or something like that that wraps up the functionality of the specific hardware, so that it's suits my particular application, right? Because like Steve was saying, just they can be very low level, like set time based trigger. I just want to do an acquisition, and maybe it combines some of those or it strips some of those things out. But also speaking to abstractions, then it makes it easier to switch it out if you do need to change your hardware, right? Because your API is then written for your application rather than a specific instrument, so that you can then, if you need to change things or want to change things, you change the underlying code just for that particular, what constitutes your application level driver or API. so that it's more easy to interchange things. That makes sense?
It does. To me, it does. For sure. And I think
you're protecting yourself from change, essentially. So you put that layer in to protect yourself from that change, which probably leads us on to the next subject.
It does. No, I was just going to say it's a great segue because Steve, I've known you for longer. We worked together before, but Brian and Casey, I met you two at GDEFCON, North America event. And to the audience watching, I would highly recommend you attend the closest upcoming one if you enjoy discussions like this. But anyway, I think it was there that Brian, I think it was you that presented on hardware abstraction layers, or HALs. So could you maybe briefly explain to us what that is? And when should we consider one? Like, what's the thing that triggers like, oh, this is what we need? And of course, Casey and Steve chime in with your thoughts. But I thought I'd start with Brian.
Yeah, so I've put a lot of thought into hardware abstraction layers, and then what Casey was alluding to is an idea called measurement abstraction layers. And the reason for having these abstraction layers is something we've been talking about for this entire time. If like I want to mitigate the risk of having to replace an instrument with a different instrument, or with more capability, with just availability, whatever the reasons are. And this is a problem that people in test and measurement have been dealing with for decades, right? It started with standardizing on things like GPIB, the IEEE 488 standard, so that everybody agrees on how the GPIB bus is going to be used. And then IEEE 488.2 that started to get into a little bit of the software about how the software is going to be used with GPIB. Skippy, the simple commands for programmable instrumentation, that language that you talk to these oscilloscopes and DMMs through, that was an attempt at hardware abstraction, so that I have a consistent way of asking an oscilloscope to, at least how I send it commands and how I get responses. And then, that wasn't really, is a good step in the right direction, but not really sufficient. And so that's where instrument driver standards like Ivy started to come in. That's also where you started to see these industry consortiums like the VXI Plug and Play Consortium, the PXI Systems Alliance, the Working Group for USB TMC, the LXI Consortium, so on. All these trying to make it so that things interoperate a lot better, so that I could go replace one device with another, whether it's within the same manufacturer or from one manufacturer to another. As I mentioned earlier, it's a place where it doesn't make sense for the industry to compete on a lot of that stuff. So the measurement abstraction layer part that Casey was talking about, there was actually a meeting that the Navy organized maybe 15, 20 years ago now, where it's like the idea was, okay, let's write down every measurement that I need in order to test all the parts on an aircraft. And let's put them in a big spreadsheet, and let's all agree on how we're going to do these measurements. And it's not focused on whether I use a DMM for that measurement, or an oscilloscope, or a spectrum analyzer, or whatever. It was just like, I'm going to focus on these measurements. And then, how do I make that the focus of my application? And I can just plug in the measurements that I need. For a lot of reasons, that didn't go anywhere, mostly because it didn't really open up the ability for the vendors to actually compete on how to make good measurements. It was just sort of an exercise in trying to write down a bunch of things into a spreadsheet, but not really agree on what those measurements meant and how they should be carefully taken. That's the measurement science that is actually a lot of what the rest of us have to focus on when we're building an application, is how are we going to do this measurement. But I do like to, so I tend to think the measurements that you want to abstract, are unique to each application that I write. Like, I know I want to characterize this capacitor, so what are the measurements I need to characterize this capacitor, and I'll write subroutines in my application that do that. And then I can choose whether I'm going to use a DMM or an SMU, or whatever the mechanism is later. as a lower level detail. And then that's where hardware abstraction layers can come in to hide more of that. So it's kind of a hierarchy of abstractions that let me put that together. So I'll pause there and let Steve and Casey chime in.
I'd probably like to talk about the cost of abstraction layers as well. So we tend to take a very similar approach to Brian with the go for the simplest option first and then go up. So we've got a plugin architecture that you can just swap in, but we don't use it for everything. We only use it for specific tasks. We have a much simpler abstraction layer that allows us to sort of embed it all and see it all. And you take those decisions on how much maintenance you want to do, how difficult that maintenance is, to really the benefits. Is swapping a necessity? I had to do the large pluggable one because I was dragging around huge amounts of driver sets just to build the application. I couldn't build the application because it had Flex Rio, it had digitizers, it had Flex Rio digitizers, it had NIScope digitizers, Tetronics digitizers, LaCroix digitizers, and each one had to have its own sort of set. All these different digitizers had their own set of drivers with their own set of dependencies, which meant if I deployed that to a customer, they'd have to sit there with Flex Rio installed on the machine. And so you move away. That's a real use case for a plugin architecture, because you say, I'll build it and I'll drop in my architectures, and then the customer doesn't have to have all of those different dependencies and the weight of those dependencies and the complexity of those dependencies. But maintaining those, which were PPLs at the time, well, it's PPLs, maintaining the PPL projects is actually quite difficult. It's an additional task compared to just having it embedded. So you're making a cost benefit analysis really on how much work I want to do, to how much maintenance I need to do, to how much dependencies I want to lug around with me. So it's those kind of design decisions you're making, and there isn't a specific answer. Some projects is going to benefit one way, and some projects it benefits another. And when one pain sort of motivates you to use one method, you go that route. But it's knowing that there are routes. If you want to go all the way and just have a plugin architecture where you drop PPL, there's a very well-known pattern to do that. And if you want to keep it all embedded in your project, there's a known pattern. But we always start with a minimum of, if it's got a multimeter, for example, we'll have a top-level multimeter component that calls the more specific multimeter stuff. So we always have two layers. So we always assume the multimeter is the thing that will be changed for a specific multimeter. So you have a generic that goes to a specific, and that's generally how an abstraction layer works. And the other thing is you approach the design of these things depending on how you want to see the source code. It was kind of interesting. So me and my original business partner, we built our first, when we were researching for the book, we built a system, and he comes from aerospace, from flight simulation, and in the way aerospace, planes are built is on communication layers. So his abstraction layer was very communication layer. I'm a test engineer, so I look at things like, that's a power supply, that's a multimeter, and I want to see in my block diagram a power supply giving a voltage to a thing that measures it, and I want to see my block diagram look a bit like the world of the hardware. He wanted to see the world in layers of communication because that's how he saw the world, and neither is wrong. It's just how you want to view your system. It was kind of interesting how we differed, but
yeah, I think also one thing that we haven't really talked about is who the end user of the software is going to be, as far as especially development, who's going to be maintaining it, right? Because that's, I find, is a huge driver of how we design our abstraction layers, to what level we go to, right? If it's going to be us again, they're going to just call us back and say, hey, we need some changes, we'll probably design things differently than if they say, all right, you've delivered the system. Now we have this new hire who has been using LabVIEW, taking core 1, core 2, but they're going to be maintaining it, right? I'm not going to, yeah, I'm trying not to dump, I probably wouldn't dump a PPL plugin based architecture in that scenario. So yeah, knowing who your audience is, I think, is a huge aspect of that cost benefit ratio, because what I would tend to do more abstraction layers, just because I've worked with them a lot. I understand them. I can more easily figure them out, versus someone else might not. They might not be comfortable with it, and that's fine. But you should be aware of that when designing, I think, your HAL or your MAL. So
Casey, have you ever regretted doing that though?
Which way?
That compromise. I did the huge database system once where I made the database a mimic for the customer because he was going to be maintaining it. So I compromised completely this database. It was awful design, and I had it all finished and he left. and I was left holding this horrible design which I compromised for him. And,
I've had something similar, where I regret, and it's usually, like I had one customer that would hire me to come in for a week and put out the dumpster fires that were in the application that somebody wrote, and I really wanted to fix them the right way, right? And that meant introducing some abstractions and more modularity, but they didn't really have a team that was, for example, I wanted to use object-oriented programming, and they didn't have a team that knew object-oriented programming. I said, how about if I teach your team how to do object-oriented programming? It's like, no, we don't really have time for that, even though they do, but they just believe they don't. And so you end up getting called back in a month to put out another dumpster fire, and it paid well, but it wasn't a very satisfying project to work on because of that. And I've had another customer, again, I designed a nice object-oriented approach to things, and then they decided that they were going to move this project to a different team that didn't have OO experience. And again, I offered to train the team, and then they again said, we don't have time for that. And so they ended up rewriting it. And so it's very frustrating when that happens to me.
It sounds frustrating.
I've probably been burned both ways, right? Like something that Steve says, where you write it and you kind of write it not as advanced maybe, and then the person leaves that's supposed to be supporting it, and then you're stuck with it and you're like, oh, I wish I had done it this way. But it can go the other way too, right? Where you make a lot of abstraction layers, and then but then the people that are using it for whatever reason can't support it. Someone moves, and then you're called in, and though in the short term, I guess it can be good, but I think the flip side of that is that it's not necessarily a good look when you are delivering something and the customer themselves, they want to, but they can't support it, and so they need to come back to you, and there might be some resentment there as well. But then I've also had success with that too, where I've written, I've done things the quote unquote right way, or at least the way that makes sense for us, and then maybe I don't hear from the client for a year or two, and they come back and say like, hey, we need to change things, and I go and I'm like, all right, let me figure out what I did here, and I look at it, it's like, oh, this is really easy to change because I made some smart decisions, and that is satisfying, right? When you come and say, you can say, oh, it's only took a couple hours or less than a day to make this change. There you go, and then the client's happy, and everyone's happy. Yeah.
Sure. And I think it's conversations like this, like we are running out of time. I wish we could continue talking, but it's like what I learned today equips me better to be able to make these decisions the next time, that if I have to develop something, or if I'm working with a consultant or system integrator that's developing something for me, learning what y'all have helped me do and hopefully helped the audience do is learn a little bit more about what are the considerations to take, what should I worry about, what should I avoid, it's not as simple as DAC Express. Let's not oversimplify it. Let's talk about longevity. Let's talk about reusability. So thank you so much for walking us through this. Since we have a few more minutes left, if you have any, let's go around. If you have any final thoughts on this, if you want to tell people how to reach out to you, or if you have also any ideas for the next panel. I feel like a natural next panel would be talking a little bit more about hows and mows. But yeah, I'll start. Casey, you were speaking last, so let's go back to you. Final thoughts.
Yeah, I think just when you're designing a measurement system, I think you should always be thinking of these, touching on the last topic, kind of the abstraction layers. It doesn't mean you necessarily have to do a lot of them, but at least think about it so that you know what the trade-offs are, and you can do your own cost benefit analysis as to what is going to be helpful for you. And if people want to reach out to me, they're probably watching this on LinkedIn. You can reach out to me on LinkedIn. If you want to find out more about Zyah Solutions, you can go to zyahsolutions.com. We have put out a lot of community tools that hopefully people find useful. And yeah, hope to talk more with everyone.
Yeah, no, it's awesome. Steve.
If you're going to employ a consultant, perhaps employ them before you buy all the hardware, and maybe ask them what hardware to buy.
Yeah.
Just saying, it would be really nice if customers did that for me.
Perfect final thought.
If you want some, I'm in the market for really easy work that people with massive budgets. So if there's anybody out there who's got a massive budget and wants to give me some really easy work, I'm your man. It's our speciality. So,
I could also tell the audience, if you have any questions, Steve will answer like this.
Yes,
No money.
straight away. I'll be all over it. Yeah, I mean, my big thing at the moment is community training. So read my blog, Random Ramblings on LabVIEW Design, and you'll see all the plots that I'm plotting.
Thanks, Steve. Brian.
So I agree with everything Casey and Steve just said. I think I come back to the thing we said at the beginning, is that LabVIEW can talk to whatever hardware you need, and it's just a matter of knowing how, some of the different options for you. And so I want to make a plug for continuing. If you're in the LabVIEW community, keep learning more about LabVIEW. There's things like GDevCon, which is, kind of the premier global user group conventions that are happening right now, and it's a great way to learn. So even at GDevCon this year, I saw somebody who gave a great presentation on an instrument plugin architecture with simulation, and I was like, this is doing a lot of what Ivy already knows how to do, and it's just sort of, they weren't aware that those capabilities existed. And going to places like GDevCon, you're going to learn what Casey's working on. You're going to learn what Steve is working on. You're going to learn what I'm working on, and what many other leaders in the community are doing, and how they're addressing problems, and some of the cool technologies that they know about. And so I encourage you to just continue that learning process. You can reach out to me on LinkedIn. I also have a website with a blog where I post maybe every few months, but I post something about LabVIEW. So it's stravaro.com, and I'm sure we'll have a link when we post this. But anyway, just again, kind of grateful to NI for hosting this and giving us an opportunity to talk about something we are all excited about.
Thank you all.
Thank you.
Thank you for joining and for educating and enlightening us. Honestly, it's an honor hosting this. To the audience watching this, I hope you learned as much as I did during this panel, and I'm looking forward to the next one. Thanks for watching. Bye, everyone.